Hey, 20-ones. In this video, what we're going to look at is solving by completing the square. I think some people also call this the square root principle. Either way, what we're going to end up doing is we're going to do some square rooting somewhere along the way because we'll have a square in it. Now, we did solving by factoring in the last lesson. The problem with solving by factoring is sometimes it's not always possible. We won't always be able to factor. So here is another method that we could try. So one of the nice things about this method is it's going to work when we're in vertex form already, when we've already had the square completed for us. So that's what this is here. So normally, like if I'm looking at A here, so say we had completed the square and we're asked to solve, right? There's us completing the square and we're solving one side's equal to 0. So now add 16 to the other side. And now I'm going to square root because that's the inverse of squaring. But here's something really, really important. When I take a square root of something, I need you to know when we take a square root of something, we get a positive and a negative. We get the primary and secondary roots is what that's called. So we need to watch for that. So up here I've got, we need to consider one important thing. When we take a square root of an equation, that we get a plus and a minus of whatever number we take the square root of. Okay, and so now we can solve. So I'm going to add 4 over, and then we've got our two solutions. It's 4 plus 4 is 8, and 4 minus 4 is 0. And again, if you want to write that in a solution set, there it is. Okay, again on B, we're partially through some work after completing the square. So a lot of times this might look like this to begin with, and maybe you had to complete the square even to get to there. So again, now looking at what's tight for me, I would square root both sides, remembering about the primary and secondary root. Then I'm going to subtract 2, and I'm going to get my two solutions. I'm going to get -8, and I'm going to get 4. And in a solution set, that would look like that. Okay, not so bad, right? Like, I mean, it's easy when it's already in that form for you. C, again, I notice that this work's already been partially done for me. The square has already been completed for me. So what I'm going to do on this one is I'm going to divide 2 from both sides. So x plus 6 squared is equal to 81. Square root both sides, positive -9, subtract 6, and your two solutions then will be -15 and +3. Okay, but now look at D. D, I just look at that and I go, okay, geez, what am I going to do to solve this? So the first thing I like to try is to say, can I factor this thing? Well, I can't, because I can't think of two numbers that multiply to 4 and add to 10. In fact, there aren't two numbers that multiply to 4 and add to 10, are there? So if I can't factor, then I'm going to complete the square. So parenthesis, parenthesis, right? And then take the middle term, divide it by 2, and square it. So that's 25. But don't forget about your balancing. So if I added 25, I'm going to balance by subtracting 25, just like that. Now, that's a perfect square trinomial. That's why we wrote it that way. So there's us completing the square. We did it earlier in the course, but now we're using this to solve. So I'm going to add 21. I'm going to square root both sides. Now, I don't know what the square root of 21 is. That's okay. I'm going to leave it as an exact value. I will not approximate a decimal here. And I'm going to subtract 5. And there's my solution. That's how I'm going to leave it. That's an exact value. So that's what I'm going to try. When I can't factor, then I'm going to try to complete that square. All right? So always try factoring first. It's a lot quicker than completing the square and then solving. And if I can't factor, then complete the square. There you are. There's solving using completing the square.